So let's start with this. We have electrical lighting. Obviously, every house has bulbs, lights, right? If you're sitting in a room, you might be having bulbs or tube lights or LEDs in your rooms, right? Which are making you see what you're seeing right now. Laptops, mobile phones, TK contain LEDs inside your glass panel. So we have seen this multiple times, and we will see that how do they work, right? So let me just choose a pen here. So it was basically Thomas Edison. Once upon a time, there was Thomas Edison, basically, who was playing with uh, different types of gases, right? Basically, he made one lamp that is called the filament lamp, which was the first ever lamp in the history of humankind, right? Which led us towards LEDs, lamps, tube lights, and so on and so forth, right? So it looked like this. If you recall your old past days, so it has a sort of a metallic base here and a glass surface and a tungsten material which is basically connected with the positive and the negative like here. Right? So what was the specialty of this material? Okay, when you pass through electricity in this particular wire, it basically glow, right? And we are able to basically see light in the darkness first ever in the human history. Okay. We are basically using it multiple times in our homes. The old ones, which basically used these sort of lamps, were not so efficient. They were 40 to 50% efficient over here. Uh, uh, Acha. So, but just recall this the filament lamps. If you recall your old days, if you have seen this filament lamp in Pakistan, they are basically found in bakeries, right? They're found in bakeries. Very basically, they use it to keep the biscuits and the pastries, not the pastries, the sandwiches, okay, warm over here. Okay, so it's sort of a desi totka over here, desi method to keep the biscuits warm here, right? So why is it basically keeping the biscuits warm? Because it produces huge amount of heat energy, which is again loss for us, right? It is consuming electricity from the K Electric or the power production company and converting it maximum energy into heat over here. Filament lamps, which were basically discovered, are only 10% efficient. Right? Imagine this. So 90% energy is going to waste, right? 90% converting into heat energy. So now, if you see your LED bulbs over here, you have Osaka and multiple companies wherever you're living right now. So they are using LEDs over here, right? So LEDs consume little amount of voltage and they produce brighter lights. Okay, so they are more efficient. You can see that they are 40 50% efficient in transferring light over here. We have more efficient lights which are basically developed in different countries, and some people like to use modern lights, and they might have this in their homes. So you can explore these type of lights. Okay, just imagine कि if you go to a shop to buy a bulb and just basically ask for a bulb which consumes less amount of power, right? And produce the same amount of brightness. So if it is consuming less, so basically you have a black box. So this is the bulb here. It can be a filament lamp. It can be basically LED bulb, so on and so forth. And it is producing brightness, right? The light, right? This is taking electricity. So if you take a bulb which consumes very small voltage, right? Let's say 5 volt I produce the same amount of brightness as compared to filament lamp. Okay. So it is more efficient, right? So because it is consuming less power and producing the same brightness over here. So we have this sort of technology available right now at the current moment. Then we have fluorescent lamps, which are basically part of electric lighting. So basically, we're learning all the components which are found in your households, which we usually see them in our daily life. But they're very important. Okay, if you go to power plant, okay, you will see these components used rigorously, right? And they have very importance over here. I will basically we will move on towards fuses, circuit breakers. We will see okay, why are they important. These are basically again fluorescent lamps. It contains basically argon gas, okay, or mercury vapor, depending upon the type of the fluorescent lamp. So in this type, we have mercury vapor over here. Again, mercury basically glows over here, right? So we have electrodes here. One is positive, one is negative, right? And a fluorescent powder to basically make it glow. ठीक है, हम to make the badness go better over here. And then we have glass tube here. ठीक है, so these were basically, if you go towards 2000 to 2010, right? So we had these sort of bulbs and lights in our houses, right? So you can ask your mother or father, ठीक है, कि do we had did we use these sort of bulbs? ठीक है, you would have, ठीक है. Again, these were using the same phenomena over here. तो यहाँ पे क्या था हमारे पास, यहाँ पे we were using basically a material that was called tungsten, right? So this material, this metal glue, ठीक है, so it basically glows when electricity passes through it. Now we basically, as the technology advanced, we basically used gases which basically glue. Okay, so when we pass electricity over here, this when this becomes positive, this becomes negative. So this mercury vapor combined with frozen powder over here, it basically produce the white light. All right. So these are basically helpful to light up your house, right? Just give me a thumbs up if you have seen these sort of tube lights or bulbs in your with your physical eyes. I believe you would have seen this. These are not so old. Yeah, may have seen those. What about Hamza and Varda? Have you seen this bulbs and tube lights here? I have seen those. Okay, I believe you would have also seen those. Yeah, okay. So fluorescent strip basically lamps, right? So they are, since they are long, okay, and also basically efficient. When the switch is turned on, mercury vapor emits invisible ultraviolet radiation, which makes the powder on the inside of the tube to glow, right? And then which basically emits visible light. We can only see visible light, right? The other spectrum of the electromagnetic wave that contains radio waves, microwaves, gamma rays are not visible to us, right? So different powders, we can use different powders to give out different colors. So you might have seen that the bulb comes in green color, yellow color, okay, red color also, and also white color. You can basically use different type of fluorescent powders to give out different energies, right? So again, you can see that they were getting more efficient, right? So as the technology advanced, we went from 10% to 50% efficiency, right? So again, we were learning concepts, we were learning phenomena which can lead towards more efficient, because we don't want to lose power, right? We're producing power from coal, okay, burning oil that are basically from dinosaur remainings, and they are going to basically exhaust soon. So we have to basically look for technology which are going to last more and be more efficient over here, right? Then the next practical part of electricity is basically heating, right? You basically do this daily, right? You iron your clothes, right? Ironing. Okay. What about electric heaters? So in winters you use electric heaters, right? Nowadays we also have electric cookers, right? We have electric stoves. Okay. We also have electric geysers, right? So what is common in all of them? Can you share ki how do they work? How do they produce heat energy? Can you give me an idea ki everything is one thing is common in all of them which produces heat energy? Can you share that particular point?
Sorry, sir, can you repeat your question?
I'm just saying कि, in ironing, you basically produce heat energy which iron your clothes, right? In heater, we basically warm up the surrounding the room, right? In electric stove, we cook, right? Which again uses heat energy. In electric geyser, we basically warm up the water, right? Using electricity. So what is common in all of them which produces heat energy? What is the principle of its working? Can you guess? How does it work?
Sir, maybe a thermostat or something?
Thermostat. Okay. So what thing produces heat energy in all of them?
Electricity?
Electricity. Okay, close. So let's see this. Let's see this. So we have a black box, right? This is the heater over here. You can just combine all of the heaters together into a heater, right? And then you're basically supplying electricity over here, and as an output, you're getting thermal energy. That is the heat energy, right? That is used to heat iron your clothes, make the room warmer, take care, cook your food, or warm up your liquid water over here, right? So if you imagine, just imagine basically what is used over here. Okay? So you have a coil set of wire, okay? And this is basically connected to your supply, right? This is positive, this is negative. So basically, when the current flows into the circuit, into the wire, right? So this is called basically electrical wire. Okay. So basically, what happens over here is as follows. As the current basically flows through the coil, it basically starts to glow. Okay. It depends upon the temperature. Sometimes it is yellow, sometimes it is red, right? So the wire has resistance. Okay. If you basically see a wire, okay, this is a wire here. So it has resistance, right? So what is resistance? It basically resists the change of flow of current, right? So as the current flows over here, the wire has huge resistance. Okay. So property क्या है हमारे पास इस वायर की? It has huge resistance, which basically leads towards what? Production of huge amount of energy, right? It produces huge amount of heat energy, right? And this heat energy is basically the output of this heater over here, which is basically also found in your iron, in your electric heater, in your electric stoves, in your electric geyser also, right? And it looks like this, right? If you see your heaters, they basically again these sort of two parallel lines glow, right? So these are wires which are mounted up over here and providing electricity through this cable supply. The wire starts to turn red, right? And when it turns red, it means that the resistance of the wire is so much that it is basically resisting the flow of current, okay, which increases the temperature of the wire, okay, because it is resisting the change of flow of current, and it produces basically what? Heat energy over here. Similarly, if you have a cooker, right, or electric stove, you also have basically what? A wire on the base and a sheet on the top of metal plate, and you can basically cook your egg or food, whatever you want to heat your food, right? Electric kettle, right? It has a again the same construction of wires at the bottom, right? And through convection, the energy flows through the entire liquid to come up to basically make coffee or tea and so on and so forth. In iron, you again have a coil at the bottom of the surface when you have a basically metal plate. It heats up the entire metal, and through conduction, the entire base becomes hot, and it is basically used to iron up your clothes over here, right? This is pretty simple over here. So this is also one of the application which you find in daily life, and this is again using electricity as an input over here, right? So if it makes sense, give me a thumbs up. How does electric heating works? Okay, makes sense to me. Makes sense to Varta. Okay, that's good, right? So let's quickly summarize this. Okay, so in domestic applications such as electric fires, cookers, kettles, irons, the element, right? So elements are made up of nichrome wire. Okay, so nichrome wire के हमारे पास क्या? It has huge resistance. It is a alloy of nickel and chromium, right? So when current flow, it becomes red hot. ठीक है, because की resistance बहुत ज्यादा होती है, current को ये बहुत resist करता है. So it in basically resisting the flow of current, it basically produces heat energy and glows, right? This is about 900 degrees Celsius. It's huge, right? Okay. And then it is basically emitting a red sort of light over here, which is reflected by the polished surfaces in the room over here. And you can see that these things are glowing over here, right? The next thing which we see in real in everyday sort of normal routines आप बैटरी चार्जर राइट जैसे imagine if you want to power up your phone ठीक है आपकी बैटरी खत्म हो गई मोबाइल फोन की टैबलेट की लैपटॉप की राइट or let's say it is a UPS ठीक है you have a battery also over there you also need to charge them right so what do you use to charge your batteries again electricity over here right so you have the main electricity coming from power production company right and this is your battery which you can connect to charge up your battery here ठीक है this is the positive terminal of the battery, negative terminal of the battery. It can go here and it go here. Okay. For this, we have DC voltage, by the way. So let me just make the entire thing. So होता ये है कि you have the power from the electrical company. It goes to basically a converter. It converts AC to DC, and it goes to your charger, right? Positive, negative. Your battery needs only DC voltage to charge. ठीक है, let's say plus it needs a constant 100 volts to charge over here, right? So in this we have a DC voltage here, which is a constant 100 volts, right? So from the supply you're getting basically a sine wave, right? So you have in between something which is basically fitted inside your chargers. Okay, the charger can basically have electrical components which basically converts the AC signal to a DC signal, right? So your mobile phone charges on 12 volt, right? So your chargers which are using at your homes, they convert 220 volt to 12 volts DC, right? So that is why your chargers are expensive, right? If you want a fast charger, they're expensive because they are going to be delicate, right? They're going to be delicately designed to give you a fast charging rate over here, right? So once we have, if we have time, I can explain कि होता कैसे. Okay, it's a university level concept. We can just discuss this briefly, right? So a battery charger transfers energy to a secondary cell or rechargeable battery by forcing electric current to flow in the opposite direction to normal current from the cell over here, right? Some rechargeable batteries, such as those used for electric car, requires a fast rate of charging, right? So, ठीक है, some batteries which are basically used for mobile phones, they need a slower rate, right? So, if you have seen or experienced with the if you use fast chargers, your mobile battery health basically decreases pretty fast, right? Because it's a drawback, right? You're pushing in the charges pretty fastly in your mobile phone batteries with a lithium, which are lithium-ion batteries, right? So if you talk about electric vehicle, ठीक है, so that thing has a huge battery at the bottom, right? The major chunk of the weight of the electric vehicle is the battery, right? It's huge. So for charging this up, the user cannot wait for, let's say, 12 hours, right? So he can maximum wait for 4 to 5 hours to charge his battery and again go on his journey over here, right? So for these applications like electric vehicles, we need fast charging over here, right? But if you recall, if you just use, let's say, call up your phone, you want to charge a mobile phone over here, okay, you can use a slow charger, right? Because you want your phone to last longer, right? So again, we have drawbacks, right? So everything has perks and cons over here. We want to decide in between over here. Then we have motors, which are basically seen. If you let's imagine what are motors. Let me just explain what are motors here. Again, motor accepts electricity as an input. Okay, and outputs basically what? It outputs a force, right? If you see a motor, हमारे पास motor ऐसे होती है. It has a shaft on this, ठीक है? And when you basically supply the positive and negative basically voltage, this knob basically rotates. ठीक है? It has a force which is basically rotating the motor over here. ठीक है? So this is a motor over here. So where do you see this in real life in your homes? You can just ask your mother or father. Okay, you have motors basically to pump water, right? Pump water into your house. Okay, not into your house, into your tanks, right? Use them basically. Use the motors in basically lifts, right? The lifts basically picks up the weight and move up and down. It has a motor, right? You basically found these motors in cars, right? The cars have basically motors over here which move the tires of the vehicles, right? And so on and so forth. You have multiple examples for where you see basically motors. Again, application of electricity. They work on electricity, and you found them in practical life, right? So electrical motors are found in many electrical appliances, from sewing machines and vacuum cleaners to electric cars and trains, right? So it transfers energy by electric current to kinetic energy, right? Again, force क्या है हमारे पास क्या है? Force causes a motion, right? So if you have force into distance, you have work done, right? And if you have basically object which is basically moving, okay? Let's say if you have a car, let me talk about a lift. It's more simpler to understand. If you have a lift, right, and it is going up by a motor, right? So it is basically producing kinetic energy, right? Right? The lift is basically moving up and down, right? Then it is saying the power required by a motor is equals to VI. We have learned the formula of power in the last chapter. But what is power, right? So if we have energy, we have power, and we what is power? It is the voltage into time, voltage into current over here, right? Then this is saying the power needed for the motor and electric car is around 100 kilowatts. Okay. For DVD player, you only need 20 watts over here, right? Just imagine this. So for a car, you need basically 100 kilowatt to basically move the tires, right? It makes sense because the entire weight of an electric vehicle is around 1200 kg, right? And if you sit on the vehicle also, you also have weight. Let's say we two-person sitting over here of 80 kilos, okay, so 160 kg also. So it has to move the entire weight. So you will have to supply huge power. That is why the electric vehicle has huge, basically set of batteries at the bottom, right, which needs to supply the power to the motors to move. Okay, let's compare this with a DVD player. It only needs 20 watts. Okay, that is where you basically see the how do you use your formulas in practical scenarios, right? You have to find out, okay, how should I design my motor such that I have 100 kilowatt of power, right? Uh, how the motor works. If you know if how a motor works, then and then only basically you will be able to design it for a particular application, right? So again, we have some good applications where we found electricity as an input over here. We also have some dangers of electricity, right? So you might have seen that whenever it is raining in your house, in your area, your mother or father tells you, don't touch any switch, right? Don't basically touch any metal pole outside your house with bare hands, right? Or wet hands over here, right? Why? Because your body is also conductor, right? Your body, let's say this is Hamza over here. Okay, Hamza is on right. This is Hamza over here. And your body is also basically a conductor, right? It is also conductor over here. Okay. So what happens if you touch the pole? Let's say Hamza wants to test. हमजा ने बोला कि सर खुदामा ने मुझे बताया था कि I should not touch the pole, but I will get a shock over here. But Hamza does not believe it. Hamza want to do an experiment here. सही है. So Hamza goes to a metal pole which has basically metal wire passing through, right? And it is raining over here at this moment. It is raining over here, right? So Hamza goes and basically touch the metal pole over here. Okay. So what happens basically when the pole is wet over here, okay? So water is also conductor, right? So water is also conductor of electricity, right? It's a conductor of electricity. So the wires which are basically carrying electricity over here, they deposit some charges on the metal pole, some electrons here. And when you make a contact with the metal pole and you also have a earth, and we know that हमारा जो earth है, that is basically at 0 volts, right? When you touch this basically pole, so you create a path for the current to flow. Okay, that is through this. Okay, so it goes from your hand to to your basically mid part of your body to your foot to the earth back over here, right? Because this pole is at 220 volts, right? And current always flows from, let's say you have 220 volts here, and then you have 0 volts here, right? So current will flow always from high to low voltage, right? So your body is just a medium, okay, which has some resistance. So voila, okay, you can basically Hamza will have a exemplary idea to basically check the concepts of physics, whether Sir Khuzaima was right or not, right? Acha, Allah na kare, if you see anything getting someone basically accidentally getting a shock from the pole, so you should always find a piece of wood, okay? Find a piece of wood nearby and just just basically try to remove his hand with the wood, okay? You can just hit him strongly with your hand, with the wood, not your hand, with the wood, so that it basically breaks the contact over here, right? So hazards which basically associates with the electricity, right, include damaged insulations, overhead cables, dam conditions, TK, that is when it is raining, excess current from overhead plugs, TK, extension leads, single and multiple sockets over here, right? So if you have, let's say, a wire in your house which is basically broken and you see that the wire is exposed from here, so if you Allah na kare touch this particular thing, you might get a shock, right? If you have a socket, okay, and you basically let's say put another extension over here, right? You put extension cable here, this extension here, it has multiple three more switches, right? And then you put another extension over here, right? And then you have another extension board here, right? And then you put another extension board here, right? So basically every socket has current rating. Okay, this can allow only this amount of current to flow. So आपने सारे extension cable लगा के let's say you basically connected up your computer with this, ठीक है? Connected your refrigerator with this board over here. Connected your microwave oven electric heater with this over here. ठीक है? So it's going to draw huge amount of current, right? And you have all using only one main socket over here, which is coming from the let's say power production house. So if you do this in your house, so it is going to consume huge amount of current that is going to produce huge amount of heat energy over here, and it basically can cause fire, right? Sorry, fire over here. That is the case if you have heard about fire in some houses. So they do this, right? They overpower the board over here, overpower the switch over here. You have to be basically be careful in this sort of scenarios here. Okay, so don't overpower anything. Whenever you buy a switch, okay. So if you see at the bottom right, it has current ratings 2.5, 2.5 A, 1 A. A is amperes, right? So the amount of current it can basically allow to flow. Okay, the maximum current. So let's see what happens when you get an electric shock, right? So electric shocks occur if current flows from an electric circuit through a person's body to earth, right? This can happen if you have damaged insulation or damaged cable or faulty wiring, right? Okay. So your human body has a resistance of 10,000 ohms, right? You can use the instrument to measure it out. Okay. So if a person touches the wire which is at 240 volts, तो you can use your Ohm's law to find out. ठीक है, तो Ohm's law क्या बोलता है? V equals to IR. ठीक है, तो जो सप्लाई आपके घर पे आती है, the voltage of that comes into your house is basically 240 volts, right? And the resistance of a body and average value is basically 10,000 ohms, right? So if you want to find out the current which can flow through your body is going to be 240 divided by 10,000, right? So if you want to make current subject, it's going to be V over R, right? So this and this cancel out 1, 2, 3. ठीक है, so it is basically around 24 0.024 amps. ठीक है, it's basically a small value. It is bearable. Just imagine, have you ever touched a socket and get electric shock? If yes, give me a thumbs up. A minute shock, not a huge one. Have you ever gotten those? Nave को लगा है, ठीक है, हमजा को भी लगा है. What about Varda? Is Varda electricity proof? Okay, Varda is safe till now, thank God. I also gotten those. ठीक है, वर्दा को लगा है. So that is you basically were able to take it out, take your finger out. ठीक है. Why? Because the electricity which comes into your house is a AC signal, right? So AC signal क्या होता है? It alternates between plus 240 and negative 240. So there comes a point when the voltage gets zero, right? So whenever you remove the finger, it was this particular point which basically will help you to escape over here. If you had a constant DC voltage, which used to come into your house, let's say, which was a scenario in 1980s. Okay, in 1980s, we basically were working on DC supply over here. Let's say if we have getting a 240 DC volt, there is no zero crossing here. Okay, so if by mistake or by any uh, mishap you touch any socket which is carrying a DC voltage of 240 volt, okay, you will have no chance to escape, right? So that is why you have seen multiple example where basically person was able to escape after getting a huge shock also, right? So this is the reason, this is the sort of the point where you can escape, right? Yeah, I hope it makes sense, right? These are not so difficult concepts. So to avoid the risk of getting shock, so these are the precautions here which you should take. Precautions. ठीक है. So switch off the electrical supply to an appliance before starting repairs, right? If you want to repair anything, let's say if your uh, socket is not working, so obviously turn off your main supply or just the supply to that particular room, ठीक है. Use plugs to remove use plug that has an earth pin and a cord clip over here. Okay, a rubber or plastic case is preferred over here, right? So if you have seen your laptop chargers, some have three pins, right? Some only have two pins. So the three pin is basically used is very important over here because the third one is basically the earth point here, right? So this does what? It takes the extra charges, which are basically, let's say, suddenly, accidentally, which piles up on the cover of the charger here, and it removes them, right? But normally in Pakistan, we have local chargers, right? We contain only two pins, right? For the live, this is for the neutral. We have no earth cable over here, right? So use the one which has basically three cables here, and make sure that your house have earth, right? Earth क्या होता है हमारे पास? How do we give earth? Let's say you have your house, right? You just connect a wire with your wall, with any one wall of your house, and dig it till 10 feet. ठीक है? So you want to dig a wire physically at 10 feet, right? So this wire is called the earth wire here, right? You might have seen the at your when basically at PMTs at your surroundings. Okay, there is a basically cable which is basically going like this with the pole, right? With every metal pole of the power supply company. So these cables are basically earth cable here, just to avoid charges which are basically piling up on the pole, right? So it takes the extra charges inside the earth, right? So this is the importance of earth over here. Every house should have one, right? Okay, so do not allow appliances or cables to come into contact with water, right? Obviously, it should not be wet. If it is wet, the water can conduct electricity and can give you a shock, right? So do not have long cables trailing across a room, okay, or on the carpet, right? If you have, let's say, an insulation which is broken, it can basically, if it comes in contact with the person, it can give him or her a shock, right? So these are the precautions which you should take to basically avoid getting electric shocks, right? Then another basically risk which can have in electricity usage over here, which are fire risk, right? We learned about an example in the last set of example where we had the power extensions, right? These over here we are basically using only one socket. We're just piling up extension boards here, right? So we're drawing huge amount of currents here, which heats up the main switch and it can basically cause a fire, right? So these are the risks basically which can be caused in case of overpowering a switch here, right? Also, you basically, if you have flammable material which is placed to a hot appliance, let's say you have a refrigerator, right? You have a refrigerator, right? And at the back of the refrigerator, you have a metal sheet, right? You have a metal sheet at the back, which basically produces heat energy, right? So if we have, let's say, a refrigerator placed too close to basically, let's say, to a switchboard, okay, or let's say extension board, okay, that can also basically heat up the board. Let's say you have extension board over here, okay, which is placed pretty close to the refrigerator. It can heat up this metal, basically this extension board, and can melt the plastic, right? And if it basically melts, obviously you know, okay, its temperature is pretty high, right? The temperature is pretty high. It can basically cause the melting, and basically current can also you have current flowing in the circuit. It can add up to basically produce a fire, right? Yes. So this is also very risky over here. So do not place your refrigerator or let's say heaters which are pretty close to switchboards over here, right? So if the electric wiring in the walls of a house becomes overheated, a fire may start, right? Let's say we have a very old house, okay? Your lights are fluctuating, but you don't care, right? Uh, and wires, if you have a wire, right? So with time, they basically get damaged, right? And there might be rainfall in your house, and there might be some leakage inside your roofs, which can basically damage the wires. So after 10, 12 years, your wire becomes pretty basically damaged here. And the insulation, which is basically the plastic around the cable, which protects the electric shock to a person, it also basically become obsolete after some years, right? Because plastic, if it is exposed to sunlight, it becomes basically hard, right? And it might break from some places, like exposing the wires. And this can lead to huge temperatures. And if the temperature is way too much, it can lead to a fire over here, right? So wires become hot when they carry electrical currents because they resist the flow of current, right? The larger the current, the larger the hotter it becomes, and the greater the fire risk over here. Again, to reduce this fire risk, we can use these precautions. Again, these are the precautions here which you can use. So these are important, right? So you can have MCQ, you can have theory questions which can ask about how can you prevent a fire, right? So you should use fuse over here, right? We learned about what is a fuse in a while. So you should use fuse always in your circuitry over here. Do not attach too many appliances and circuit via extension leads, which we just saw in the last example. Do not overload circuit by using too many adapters. Again, example of extension. Do not, if you are using single socket over here, connecting multiple extension boards, okay, you can again heat up the sockets, right, and cause a fire. So appliances such as heaters use large amount of power, right? So do not connect them to a lighting circuit, right? So you'll see that in a house we have multiple circuitry, right? This is an example of a house over here. Okay, how do you power up your house? Okay, you might have an electric meter which counts up your units which you consume throughout the day, which are fixed outside your houses. Then the supply is coming from your electric meter to your house, okay, to your room, to your sister's room, to your father's room, okay, to your drawing room, so on and so forth, right? So we learn about wiring and a wire कैसे करते थे हम, ठीक है? So the summary of the sort of risks which can have basically using electricity are as follows. So if you have damaged insulation, okay, that can cause a risk of electric shock and fire. If you have damaged cables, it can lead towards fire risk, right? If you have dam conditions, let's say it is raining outside, it can basically severely give you electric shock, right? If you're overloading, okay, which we saw extension board putting multiple extension boards on single socket, it can again basically give you both fire risk and a electric shock over here, right? So these are the sort of risks which are sort of that can be caused by. Okay, so these are the risks which basically learned. So we learned applications. कि हाँ, we found these electrical applications in real life, right? We have seen what are the risks which is basically caused through electricity, right? But we have precaution which we can take. Okay, so don't be scared. Okay? This is a sort of technology advancement which we are going through, right? Let's imagine if there would be no electricity, there would be no industry working, right? There would be no industry because every industry has basically requirement of electricity to work out their machines, right? So just imagine the importance of electricity, right? There would be no industries. So if there are no industries, we won't have any, let's say, food materials like let's say Coca-Cola or let's say Dew, 7-Up, Pepsi, or let's say the chicken wings, so on and so forth, right? So I can think of the chicken chicken nuggets right now. So we have multiple things which are basically produced by a company industry like electric vehicles, bikes, so on and so forth, right? This is the importance of electricity, right? Now just imagine that you want to power up, you want to basically create wirings in your house, right? You have let's say multiple rooms, okay? So we are now only talk about the circuitry, right? Okay, how does a electrical engineer in your house basically places the wirings uh, in a designed way such that you don't have any issues, any shortings, okay? Any electrical shock scenarios, okay? It should also have safety, right? You should also have a earth and so on and so forth, right? So I want you to look at this. I want to zoom in here, okay? So just see this over here. So I'm going to just give you a summary from my cursor here. So this is the meter, right? Which is found outside your house. If you can see readings, units showing over here. Okay, how many units have you consumed? This is the power supply company side over here. So यहाँ से आपके पास आ रही है. You're getting two wires here. L means live wire, N means a neutral wire here. Okay, so whenever you have a supply to your house, you have two wires coming into your house. A live wire and a neutral wire here, right? So live basically contains the current. Neutral is basically the return path over here, right? So you can see a box over here, a square and a wire passing through it. This is called a fuse. Okay. This is present at this company's side over here, right? जहाँ से आपका electricity आ रही है. Then when it comes to a meter, it gives a regulation over here कि how many amperes, how many joules are you consuming, right? Okay. So then this is a consumer unit over here. What is a consumer unit? Okay, this is basically your house, right? So you are basically now going to supply your different parts of your house over here, right? So you have consumer unit, you have lighting circuit, you have ring main circuit over here, right? So what is a lighting circuit? It just connects all of your light bulbs in your house, right? And you also have a earth wire here, right? You have an extra earth wire going to the ground and 10 feet down. So basically, just carry away extra charge which basically gets up on your plastic board or switch board and so on and so forth. Right? So we can see for every bulb we have a live wire, we have a live wire, we have a live wire, and back it goes back to the neutral wire, which is coming from the supply here, right? We have switches over here, right? You can see switches here, right? So you can also control the switches from your main circuit breakers. You will see what are circuit breakers in a while, right? And then you have fuse here, right? Which are going to different circuitry here, right? What is the ring main circuit over here? A ring main circuit is basically doing what? It is basically protecting the circuitry which are present on the left hand side, right? So you have some circuit breakers here, right? Some circuit breakers here, some circuit breakers here, right? So it basically provides uh, electricity to different parts of your house, right? So this basically can connect it to a cooker over here, right? And this basically is connecting back to the earth to give basically to protect your wiring in your house. And this is basically taking the connection to a different part of your house over here, right? So this is a entire connection of electricity in your house, right? Which you can check. You can go to your power side of your house. Do not touch it. Just open the box with the presence of your father and just check it out. Okay, what the parts do you have? Okay, we'll discuss some parts over here which are going to match your things which are present in your house right now. Okay. So the first thing which you have, acha, circuits in parallel. Okay. We basically provides supply to circuits parallelly. Okay. Let's say this is room one lighting, right? This is room two lighting over here, and this is room three lighting here, right? Let's say if there is a fault here, if there is a fault here, right? So you can still basically supply electricity to your room two and three, right? It happens, right? It happens if the one room can have a faulty wiring, so the other rooms have basically working fine over here. Just imagine if you have a series connection. This is room one, this is room two lighting, this is room three lighting here. So if any room basically have a fault, the current basically stops to flow and all the rooms are basically down. All the room basically are disturbed over here. So we basically design circuitry for your house in parallel way, such that if you have fault in any one room, the other rooms are basically working fine. And it's also easy to basically find out the issue, right? If you know okay, room one is not lighting up, you have only issue over here, right? So in series, you won't know okay whether you have issue in room one or room two or room three. So your basically electrician will have to check every part of your room, right? So this is basically how you basically lay out the connections of electrical supply in your house. Right? So now let's move on to some parallel circuits. Okay. Just I'm going to summarize this. We discussed this already. So every circuit is connected in parallel with the supply that is live and neutral. Right? You can see it has a live neutral. It has a live neutral. Okay. Neutral यहाँ पर है basically. It has a live, it has a neutral over here, right? So every room has its live and neutral wire, so it has different circuit, complete basically separated circuitry over here, which basically keeps it isolated and safe. Okay. The advantages of having appliances connected in parallel is that rather in series, the potential difference across each lamp is fixed. Okay. Each lamp can be turned on and off independently. So if one lamp fails, the others still basically work, right? This is the benefit of having connections in parallel over here, right? So if it makes sense, give me a thumbs up quickly. How do you lay out? How do you basically see electrical circuitry wiring in your house? Okay, it makes sense to Balda, Maybe. What about Hamza? Okay, good, right? Then we learned some instruments which are used in safety of your wiring, right? I'm going to draw symbols and circuitry also over here, right? The symbol for this is basically as follows. For a switch, we have a symbol which is as follows, right? This is a switch over here. How do you connect this? So if we have, let's say, supply, right? It always comes with the live wire in series, right? And then you have your lamp here, and this is the neutral over here, right? Okay. So this is the switch over here. What it does, it basically protects. It basically controls whenever you want to turn on or turn off the lamp here, right? So switches and fuses are always in the live wire, right? If they were in neutral, light switches, power sockets would be live when the switches were off. Okay, and the fuse they would be melt over here. So basically, conventionally, we basically believe that the supply move from positive to negative over here. So live wire is actually the positive and neutral is negative over here, right? So it is always important to basically block the supply from here, right? So if you put the switch instead of this till here, so the current would still move till the lamp and would basically destroy the lamp over here if we have excess current flowing through this particular circuitry over here, right? So it is always kept in series with the live wire. Okay, so L means live wire. Okay. A fatal shock could then be obtained by, for example, touching the element of electric fire when it was switched off. Okay. So they are saying कि if you place your switch here, ठीक है, and so this would be connected over here. So if you accidentally basically touch any, let's say, part of the wire which is exposed from here with your hand, right? So you know current यहाँ तक तो आ रहा है हमारे पास, ठीक है? So if you touch it, the current would flow through your body also, give you a shock over here, right? बिकॉज आपने लाइफ का पाथ आपने ओपन करा क्लोज करा हुआ है, ठीक है, वहां से करंट तो फ्लो हो रहा है, ठीक है, यू ऑलवेज हैव टू प्लेस द स्विच वेयर इट बेसिकली विद द लाइफ वायर, ठीक है, ठीक है जी. So if it makes sense, what are switches and how do we use them? Give me a thumbs up. Okay, makes sense to me. What about Vardha and Hamza? ठीक है, good, सही है. So now we have fuses over here, right? So what is the fuse? So electrical symbol of a fuse is basically this. The symbol of a fuse is basically this. A wire goes through this. Okay. And how do you place this? If you have a circuit which contains AC voltage as an input, and you have a, let's say, you also have a lamp. Let me just place the switch also. And this is the fuse here. This is the voltage, and this is the lamp here. So this is the fuse, and this is the switch here, right? So switch basically controls the turning on off of the lamp over here. What is the purpose of fuse? Right? So every fuse has a current rating. It has a current rating. It basically limits the amount of current to flow. Let's say इसकी limit है हमारे पास 2 amperes. It can allow a maximum current of 2 amperes in the circuit. Let's say if your current in the circuit becomes 3 amperes. ठीक है? So this fuse has a wire, ठीक है, which would melt if your temperature, if your current basically is greater than 2 amperes, right? So what happens if the current in the circuit becomes 3 amperes? This wire basically breaks. And if the wire breaks, there is no path for the current to flow. And it basically turns off the circuit over here. It protects your applications. Okay. Let's say if you have a refrigerator, an air conditioner, right? Let's say pitches say from the supply, the current exceeded because of a fault, right? So if you have a fuse in your house, it would basically blow up the fuse and protect your applications, okay? And it will basically turn off the power supply to your house, right? So a fuse protects a circuit. It is always placed in the live wire, right? So this is the live wire here, and this is the neutral here, right? It is a short length of wire of material which basically has a low melting temperature. So we usually have tint copper over here, which melts and breaks the circuit when the current exceeds a certain value, right? That is the rating of the fuse here, right? So two reasons of for extra current which basically falls through your circuitry is basically short circuit, okay, due to bond insulation, okay, and overloaded circuits over here, right? So which happens throughout from this power supply production company. If there's a fault in their side, they might basically cause of increase of current, okay, and that might basically cause the current to increase. If you want to save your refrigerator or air conditioner, so you should have these fuses in your house, and you have them in your house, okay. Just check them. Okay? I'll just show you right now. कैसे दिखता है हमारे पास. So without the fuse for wiring, they become hot and they can cause a fire, right? Obviously, when you have huge current flowing in the circuit, it will melt the wires. It will basically produce extreme amount of heat energy and might cause the firing to start, right? It looks like this. This is the symbol over here. This is the symbol over here. Oh my god, my symbol spelling is way too good. It's a symbol here, right? And this is the physical sort of layout, right? You have them in your house, okay? So you see basically a wire here, right? A wire passing through this. This is a wire, okay? Fuse wire, okay? And these are the insulating holder. Just the holder cases over here to hold the fuse here, right? You fix this inside this, okay? So what whenever current exceeds, this basically wire breaks. This wire breaks, and it basically breaks the path, okay? And the your electricity in house goes out, okay? You can just basically buy a new fuse and replace it. And when your your power supply gets normal from the company side, just change the fuse and it will work perfectly fine, right? So it just protects your appliances, okay, which are pretty expensive, right? Okay. I believe you have all seen these in your house. Okay. So these are called trip switches or circuit breakers, right? These are very important in your house also. Okay. And you might have seen this case, they turn on upper, right? So to power up your house, you need to basically push them up, right? So when the current basically exceeds a certain value, it goes down automatically, right? So what are circuit breakers? Trip switches, also known as circuit breakers, are now used instead of fuses. Okay. So you might basically you usually have this in your houses. Okay. Fuses were basically used before. Okay. They now, yeah, they also used, but at the side of power production companies, when they want to basically find out कि हमारा fault कहाँ पे हुआ है. Just imagine a huge power cable lines. Imagine huge power cable lines, right? So if you have, let's say, power coming from here and it basically goes underground, ठीक है, and you want to find out the fault कहाँ पे हुआ है, तो you basically place fuses in their lines, ठीक है. So जहाँ का basically fuse जल जाता है, it becomes black, ठीक है, it becomes dark gray. So ये they know कि हमारा fault यहाँ पे हुआ था, they can simply change the fuse and fix it out. And also it protects also the cables from burning out, ठीक है. But usually in the houses we basically place these over here. So what happens? It turns on here, it turns off here, right? So again, it has current ratings, right? It has current ratings. That is the amount of current which they can allow to flow. Let's say 2 amperes current rating here. If the current rating becomes let's say more than 2 amperes, it will basically automatically come down. Okay, it protects your house. इसमें फायदा क्या हमारे पास? It does not burn. It does not basically burn out. You just basically move it up and it turns on the supply, right? So they contain electromagnet, right? When the current exceeds the rated value, the circuit breaker basically turns off. So this is basically how it works over here, right? Let me just show you कैसे काम करता है. Basically, I have two wires, two circuits here, है, ठीक है. एक तो सर्किट आपके पास ये है, and then you have this basically switch here. Uh, Let me not show you because I'm confused now. Then this is not required to basically learn how do they work. Just imagine कि what are circuit breakers, कैसे काम करते हैं. I don't want to confuse you guys because these are some high level concepts. कैसे काम करता है. चलें, let's skip it out. So let's just understand कि what is a circuit breaker. ठीक है. So I don't want to confuse you अभी. So it just basically helps with protection, and this is basically circuit breaker, the physical appearance here, and earthing, right? So what is earthing over here? So a ring main circuit has a third wire which goes to the top socket on all power points, and it's earth by being connected either to a metal water pipe entering the house or to basically the earth or the supply cable, right? So water pipe जो आपके पास आते हैं in your house, let's imagine this, ठीक है, this is your house, wow. So let's say the water is getting pumped from the bottom, ठीक है, let's say 300 feet, right? ठीक है. So let's say you have a metal wire, metal sort of pipe here. You simply just put a wire here and just put it in your house. So it is automatically earth here. But if you don't have these sort of scenarios of water pumping in your house, you will have to basically dig a wire at least 10 feet in the ground, right? At least 10 feet in the ground to basically have the grounding earthing mechanism complete. Okay. So this third wire is a safety precaution to prevent electric shock. Okay. Uh, electric shock should an appliance develop a fault over here, right? So let's say if we have a refrigerator, right? And refrigerator, of course, we have a body of the refrigerator, right? So if we have any fault here, some electrons might basically get on top of the metal body of the refrigerator, right? So if you touch this particular refrigerator, you might get the electric shock, right? So if you have earthing in your house, this basically earthing takes the extra charges into the earth and protects you from getting shocks from your appliances, right? Okay. So then we have double insulations. Okay, you could have cables with double insulation, right? That is containing double layers of plastic. Okay. And this is the metal wire which is inside these two layers. Right? So this helps again protecting from electrical shocks. Okay, and letting to the safe use of the appliances over here. Vacuum cleaners are widely used by humans, right? Hair dryers daily used by men and women both. Okay, food mixtures. So they are basically have cables which are double insulated, right? So they such that if the wire comes in your contact of your hand, right, it comes multiple times when you use a vacuum cleaner or a hair dryer, right? So it should basically be doubly should contain double layers of insulation to protect you from electrical shock, right? So connection to the supply is by two core insulated cable with no earth wire and the appliance is enclosed in a non-conducting plastic case, right? So any metal attachments that the user might touch are fitted into this casing so that they do not make a direct connection with the internal parts. Okay, so just saying के the let's imagine a dryer, okay, a hair dryer, right? Okay, a hair dryer over here. So what is happening over here? So this is a wire. This has a wire, okay, which is basically connected to the power socket here, right? So again, you all have seen that the body of a hair dryer is always plastic, right? And it has a cable which has double insulation, right? So double insulation protects you from the connection with the main wire from the supply, right? And the motor inside this particular hair dryer it has also electrical inputs. So to avoid the contact with the electrical motor inside the hair dryer, we have a plastic body. And plastic is basically what? It's an insulator, right? So it does not allow the current to pass through and it basically leads towards a safe use of the any appliance over here, right? So we have no risk of a shock to develop basically into the scenario here, right? This ends up the chapter over here, and I believe it was not so difficult, right?